we are going to talk about operations on functions. That means adding, subtracting, multiplying, and dividing functions, as well as compositions of functions. So if you go to this lovely little box that we have here on our page, what you're going to see is some notation. And that is the notation for adding, subtracting, multiplying, and dividing functions. And in this case, they're talking about the functions f of x and g of x. So this notation right here, f plus g of x, means take f of x and add it to g of x. This notation, f minus g of x, means take f of x, subtract g of x. This notation right here with the dot, that's our dot for multiplication. F times g of x means take f of x, multiply it times g of x. And f over g of x means take f of x, divide it by g of x. All right, so we're going to start off doing this. This is pretty straightforward. Compositions are a little bit more complex, but I think you'll find that this is not too bad. So we're going to go ahead and go down here to example 1. So f of x is this, 4x plus 7, and g of x is the square root of x plus x. Okay, lovely function there. And what we're going to do with them is add them, because we're asked to figure out what f plus g of x is. Keep in mind that this means take f of x and add it to g of x, which means take 4x plus 7 and add the square root of x plus x. All you're doing is adding the two functions together. Once you do this, you do need to simplify like terms. And so this will equal, I can take 4x and add an x to it. So I've got 5x plus 7 plus the square root of x. Right there, beauteous. Okay? If I go over here to f minus g of x, I am doing the same basic thing, only I'm doing subtraction. I am taking f of x, and I'm going to subtract g of x. One little catch about doing this, however. You're going to take f of x, which is 4x plus 7, and you're going to subtract g of x. Keep in mind, if you're subtracting the whole g of x, best to put it in parentheses and distribute that subtraction to the whole thing. So this would give you 4x plus 7 minus the square root of x minus x. Now go ahead and combine your like terms. 4x minus x gives you 3x plus 7 minus the square root of x. All right? So if we go down to the bottom of the page here, we're going to do a little bit of multiplication and division. So f times g of x means take f of x, multiply by g of x. Now this brings up one really interesting thing, and I don't know why this is always a problem, but when you all go to do your homework, this is always a problem. Somebody will even do it on the test, I guarantee you. Do you see how up here f of x was this and g of x was this? Okay, these have new directions. So f of x is now this, and g of x is now this. They're not this anymore. This has new directions. So when you're doing your homework, make sure you pay attention to the directions for that problem, or you're going to be totally off. Okay? So this is f of x is x squared minus 9, and g of x is x plus 3. What do you suppose you need to do next? FOIL, exactly. And I know you know how to do this. So we would have x to the third plus 3x squared minus 9x minus 27, right? When we FOIL, we all agree on that? Did we go wrong anywhere? Yes, no, we're okay? Okay. All right. You're going to love this one. Division is kind of probably the most painful out of them. We've got f of x over g of x. So f of x on top, g of x on the bottom, and that is going to give us, do I have room on the screen? Yes. X squared minus 9 over x plus 3. Now, I do need you to go and in your brain access your Algebra 1 materials because we know how to simplify this. You just haven't done it in a long time. So when you have your rational expression, which is what this is, because a rational expression is a fraction, you need to factor your numerator and denominator. And we know that the numerator factors as x plus 3, x minus 3, right? Now we can only cancel common factors, so I'm going to cancel my x plus 3's, and this is going to equal x minus 3. Lovely, isn't it? Okay, let's go over to compositions of functions. Now, compositions of functions have a different notation that I'm sure you haven't seen before, and you'll see the problems given to you in the book in one form, but I kind of think that there's another form that makes it a little bit clearer. A composition of a function is when you take one function and you put it inside of another function. All right, and that's what we're going to do. Now let's go over the notation first. So I need you to see something here. Here's an example of the notation. This little tiny symbol here is not a dot. This is a little tiny circle, like degrees. If you were writing degrees Fahrenheit or degrees Celsius, it's a little teeny circle, okay? Not a filled in dot like multiplication. Little tiny circle. A different way of writing it would be like this. So, as an example, G, this is called G of F of X. So let's write that in here. This is G of F of X. G of F of X. That's how you say that. And you can also write it this way. I'm going to do the one that's in reverse order because you can do them in reverse and the answer is completely different. So if you have this, f of g of x, you can also write it this way. And what you notice in this case is that second function goes inside the first one. So the g of x goes inside the f function. All right? Whereas here, the second one was f, and it goes inside the g function. So first of all, we're going to do this with numbers, which is easier. And once we do it with numbers, we're going to do it with variables, which is a little bit harder. All right, so let's go down here to example 3. So this is f of g of negative 3. So here's how we can rewrite this. There it is. Here's what we need. We need this. This is first. We need g of negative 3. We need to know what that is, g of negative 3. So I'm going to go over here on the side, and I'm going to do this. You know how to do this part, right? G of negative 3 means negative 3 squared, which is 9, right? So far, so good? Haven't lost you yet? Okay. So this thing, I found out that g of negative 3 equals 9, so I'm going to replace g of negative 3 with 9. So this equals f of 9. Now I got to go to my f function, which equals 9 minus 5, which equals 4. All right, so we're going to do the same number, x, the same x, negative 3, no, but we're going to do it in reverse because we have the g first. So this is g of f of negative 3 because the g came first. All right, so this, we need to find the f of negative 3. Well, let's do this right here first. That's what we need. Let's go over here on the side, and we're going to find f of negative 3. f of negative 3 equals negative 3 minus 5. So far, so good, which equals negative 8. Put this in place of f of negative 3. So this is now g of negative 8. All this is just a lot of substitution. All right? So now g of negative 8 means negative 8 squared, which is 64.
How do you know which ones you do first again?
You are going to do first whatever is inside. Are you looking up here? I'm pointing to the one inside.
Oh, I thought you meant...
And the inside is your second one. The second one goes inside, the first one goes outside. See, the F first goes outside. G is second, it goes inside. G is first, it goes outside. F is second, it goes inside.
Okay.
All right, now here's what we're going to do. Go down here to example 4. In example 4, we're going to do this, but we're not, we don't have numbers, we have variables. Okay, so it works a little bit different. All right, so I have c of x and d of x. So this is c of d of x, which, keep everything in the same order, c of d of x. So I'm going to underline this. Okay, this is a little bit trickier. You kind of got to get used to looking at this. What is d of x? If we look at this, isn't d of x 0.9x? Okay, let's substitute it. Okay, here's the deal. We're now going to look at our c function, which is right here, and we are going to put whatever is here in place of x. Whatever is here goes in place of x. So this becomes 0.9x minus 5. All right, we're going to do it in the reverse order now. D of c of x. So this is d of c of x. And this is what's inside. So we need to substitute that. And c of x equals x minus 5, right? So this becomes d of x minus 5. We don't actually care what's there. You can do it with anything there. Now what we're going to do is we're going to take the x minus 5, we're going to go to the d function, put it in place of x. So this becomes 0.9 times x minus 5. You could distribute this if you want, or if you don't want, you don't need to do it. I guess I don't really have a preference on this particular example. I honestly don't know which way the answer key is going to come out to be.